Hello everyone. Welcome back to Learning Science Q&A. Today we are here with our part 5 lecture of atoms and molecule. This is a chapter from class 9th NCERT, chapter number 3. So in last lecture, we have already talked about the law of constant mass that says that the mass can neither be created nor be destroyed in course of a chemical reaction. We have already discussed about the statement for the law of definite proportion, which says that a pure chemical compound contains the same element combined together in a fixed proportion by mass, and this is irrespective of the source of the compound taken. That means we have already discussed that if a water sample is taken from different sources, no matter from which source it has been taken, the proportion of hydrogen and oxygen by mass would be always 1 is to 8. And same applies for ammonia, where the proportion will be always 14 is to 3 for nitrogen and hydrogen. So let's get started with few numericals or numerical based question that can be asked in the examination, or few questions that would be based on the similar pattern. So let's read it together. We have 5.250 grams of lead combined with 2.541 gram of oxygen, which gives lead peroxide, which is PbO2. Lead peroxide is also synthesized from another method by heating with silver nitrate, and from this method the percentage of oxygen obtained is around 32.61. Now, as per the law of constant proportion, no matter from which method lead peroxide is synthesized or formed, the proportion of the element forming lead peroxide, that means lead and oxygen, will be same. So let's see this. Weight of lead peroxide is given as 5.250 and 2.541, that combines to 7.791. Now, from this 7.791 gram of lead peroxide, we have 2.541 gram of oxygen. That means remaining is our lead, right? This is what we have seen here. So if we are having 100 gram of lead peroxide, that would be having around 32.61 gram of, you can say, oxygen. Why? Because we will simply take a percentage of the oxygen in 100 gram of lead peroxide. So the amount of oxygen is 2.541 divided by the total weight of lead peroxide multiplied by 100, that gives us 32.61 gram, which is the oxygen. Now let's see the next question. We have 1.375 gram of cupric oxide, which was reduced by heating, and the weight of copper which is found or remained was around 1.098 gram. In another method, 1.179 gram of copper was dissolved in nitric acid, and the resulting copper nitrate was converted into cupric oxide by ignition. Now the weight of cupric oxide formed here is 1.476. Now, is this going with any of our law of chemical combination? We have been provided with the different masses, and definitely whenever you are going to solve any question based on law of definite proportion, we will always have a compound from two different methods. So now see how we can do these kind of question. In first experiment, we have copper oxide weighing 1.375 gram, and after reduction, the copper left with us is around 1.098 gram. Definitely, the remaining weight is constituted by the oxygen. So, oxygen present is taken or is calculated by subtracting the copper weight from the total weight. So, what we get here is the 0.277 gram. For calculating percentage of oxygen in cupric oxide, we have 0.277 dividing 1.375 multiplied by 100. That means we are calculating the percentage here. So 20.14 is the percentage of oxygen present in the copper oxide. Now we have another method also in which the total copper oxide is 1.476 gram, and copper which was taken for making this copper oxide was around 1.179 gram. Now the oxygen present in this copper oxide is around 0.297 gram. So to calculate the percentage, we'll divide 1.47, which is the total gram of copper oxide, by copper weight, and we'll get the oxygen's percentage as 20.12, which is in tally with the oxygen percentage we obtained in first experiment. So we can say that these data or the information provided with us goes true for the law of definite proportion. Similarly, in next question we have, in an experiment we have 1.288 gram of copper oxide which is obtained from 1.03 gram of copper. In another experiment we have 3.672 gram of copper oxide which gave on reduction 2.938 grams of copper. So we have to check whether these details or figure verify the law of constant proportion. Again, we are not provided with the mass or the percentage of the oxygen. So for first experiment, mass of copper is given as 1.03 gram and total mass is given as 1.288 gram. So the mass of oxygen is calculated by subtracting the mass of copper from the total weight, which is coming as 0.258 grams. Now, the ratio between the copper and oxide is obtained by dividing it as follows. We have 1.03 divided by 0.258. What ratio we get here on simplifying it is around 3.99 is to 1. So 3.99 can be easily written as 4 is to 1. So right now we are taking 4 is to 1 is as the ratio between the copper and oxygen in, you can say, copper oxide. Now in second experiment, the mass of copper is given as 2.938 gram and mass of oxygen we have calculated by subtracting it from the total mass of the copper oxide, which is given as 3.672, which is coming as 0.734. So for calculating the ratio, we have again gone through the same method, and ratio obtained here is around 4 is to 1. Now we can say yes, these figures do verify with the law of constant proportion. Now student, just see one more very interesting thing why I have taken both these questions. In this one, first example, we have calculated percentage of oxygen in copper as 20. That means that automatically says that the percentage of copper in copper oxide is around 80 and percentage of oxygen is around 20. So that is already making them in a ratio 4 is to 1, right? So what I want to tell you here is that these information are standard, and these can be used in any such kind of question. Even during examination, if you have provided with the ratio and if you remember these questions, you can surely go for the answer, that the ratio between copper and oxygen in copper oxide is 4 is to 1, which is the standard ratio. Next, we have 0.25 gram of a sample compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and about 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. Now, this question will be done in the way we are calculating percentage. Nothing special will be here, right? We have percentage of boron in the sample as 0.096 divides 0.24 multiplied by 100, that would give around 40%. Similarly, percentage of oxygen can be calculated by merely subtracting the percentage of boron, or it can be calculated by using the percentage formula. So that would come around 60%. Next, they are saying that hydrogen and oxygen combine in a ratio of 1 is to 8 by mass to form water. We have already seen, and again I would say that 1 is to 8 is the standard ratio. It can be used anywhere. What mass of oxygen would be required to react completely with 3 gram of hydrogen gas? Now, 1 gram is utilizing 8 gram of oxygen. So, 3 gram will utilize 3 times of the 8 gram. So, that would be simply 24 gram of the oxygen will be required to completely utilize 3 gram of hydrogen. Next question says a sample of ammonia contains 28 gram of nitrogen and 6 gram of hydrogen. Another sample contains 15 gram of hydrogen. Now find the amount of nitrogen in the second sample. Now the ratio of hydrogen and nitrogen in ammonia is 14 is to 3 or 3 is to 14. We have already seen. Why I am saying 14 is to 3 when I am writing it like this, right? Why they have written 3 is to 14? Because they are using hydrogen first and nitrogen later, right? So according to law of definite proportion, the hydrogen and nitrogen's ratio in any sample of ammonia, no matter from where it has been collected or prepared, must satisfy 3 is to 14 ratio. So, if the another sample is also of ammonia, then this ratio must be there. So, to calculate the weight of nitrogen in second sample, we can just simply equalize the both values. Like 3 is to 14 is equal to 15 is to x. And in this way, it can be solved. The answer is 70 gram of nitrogen would be there. After looking to few questions which are based on the law of definite proportion, we'll begin with the atoms and their symbol. Now earlier there were different kind of symbol tried and tested for elements, but they were not that acceptable. They were not that successful. At that time, Berzelius suggested that the symbol of element can be made from one or two letter of the name of the element. And at this time only the UPAC naming system came into existence, which is International Union for Pure and Applied Chemistry, according to which most symbols of the element are the first letter of the name or the two letter of the name, right? They will be either one letter or two letter symbol. And if they are having two letters, then the first letter is uppercase and second letter is lowercase. Like in case of aluminium, this. Like in case of sodium. And if only one letter symbol is there, the symbol is in uppercase only. That means it is in capital only. So we'll be looking to some symbols. Before that, we'll see atomic radius, which are measured in a nanometer. These are the relative sizes of the substances. Now see, atomic radius is measured in nanometer. 1 nanometer is 10 raised to power 9, right? So 1 meter is basically equal to the 10 raised to power 9 nanometer. Similarly, if we talk about the size of the hydrogen atom, it is around 10 raised to power minus 10. If we talk about the molecule of water, it is 10 raised to power minus 9. A molecule of hemoglobin is 10 raised to power minus 8. A grain of sand, which is so tiny, is 10 raised to power minus 4. An ant, 10 raised to power minus 3. And an apple, 10 raised to power minus 1. So these are the relative sizes of the radii in meter. However, when any question based on these sizes will be asked, most probably they are provided with the questions. Now, lastly, we'll be looking to the symbol of the elements. As we told, that symbol of the elements are mostly the first letter of the name of the element. If it is having only one letter, then in that case, the symbols are the capital letters. And if they are comprised of the two letters, then the first one is in uppercase, second one is in always and always lowercase. One more thing, we have few elements where the name that we know and the symbol do not tally with each other. Like in case of sodium. According to us, silver should be Si, which is actually silicon. Gold should be Go and L could be Le. So these names have been taken from the Latin origin name. Like copper is cuprum, that is why it has symbol Cu. Gold is aurum, iron ferrum, lead is plumbum, that is why the symbol is Pb. So in this way these symbols have been taken. In next lecture, we will see how these elements based on the valency over them combine with other element to form suitable compound. If you are watching this video, please like, share and do subscribe to this channel. Thank you.